Okay, so I stopped talking about the 2018 code and why somebody would do something the way they did it. It was definitely in, we'll just say some, not that pink would be important, but some insulation's benefit to make it where spray foamers had to coat the entire attic with thermal barrier. Would you all not agree with that? When I consider it to be over $1 a square foot, that might really bring the price in line to help me convince people to do things differently. So what they did was they proved that water or wet air is lighter than dry air. Wet air has a molecular weight of about 19. Dry air has a weight of about 27. Wet air rises. As it rises up into the attic with open cell foam, we get what's known as a ping pong effect. Some of it goes in, some of it bounces right back out, but sometimes you miss, and that water stays. So they decided they needed to ventilate attics. Well, once you open mechanical in an attic, you now need either a life safety valve, which again, we're getting, everything's going to be over $1,000. So, you run these so that you make your competition more expensive. So you can throw a dehumidifier up there, life safety valve, or open 50 CFM of supply, which means thermal barrier. Either way they did that, and we'll get into it when we get a little farther into the code. We're going to talk about the new closed attic assemblies. They did this because they are now doing closed attic assemblies with air permeable insulation, meaning fiberglass and cellulose. They needed that done because their product will allow moisture to go to the roof. So we'll talk about that design. The other thing about the 2018 code, the reason I think you guys may just skip over the 2012 and the 2015, the 2018 code is a relaxed standard. The 2012 required, if you're going to build with 2x4s, you have to put insulation on the outside of the structure. Its main target was thermal bridging. So either you were going to do 13 in the wall and 5 on the outside, or you're going to do 20 in the wall, 2x6s. So the 2012 code, a lot of people rejected it because how many builders really want to change what they do with bricks and sticks and start extending window jambs, doing larger brick molds, and putting insulation on the outside? Very few. So a lot of them jumped over the 2012 to the 2015 because that allowed the ERI score, the Energy Rating Index. I love the ERI score, except when it first came out, they made it really tight. I mean, they tightened down the screws like no tomorrow. They wanted an ERI score of 50 when currently, if I build to 100% of the 2012, that would be a number 70. So this is a really, really incredibly tight house and well insulated and all of that. We have to give them a shower that doesn't work, and they're not allowed grass and all that. So, you guys understand when I talk about the scores. So the issue is the 2018 code says, hey guys, you think you went a little too far? And so they took about 10 points back off, and now we're back into the 60s on that number. So you get the idea. Anyway, on crawl spaces, a couple of things I didn't even address. You look at this and this. There are some things happening. You guys don't have termites, do you? Yeah, okay, so we really need to talk about this a little more. Spray. So something is, all of the pest control manufacturers are backing away from warranties if there's not an inspection strip. Depending on the area, they want 3 to 6 inches up at the top, up here, where they can see the mud tracks. If they don't see where they can see that, they deny the warranty and they will walk away. So if your guy is foaming all the way up till he hits wood, that customer's going, or that homeowner's going to have some real trouble. So they want that inspection strip there all the time. And just to touch back on ventilation and non-ventilation, really the choice is, do you want it ventilated or not? And if you're going to make that ventilation connected to living space, it's got to be a thermal barrier. I don't care if it's just one side. If all it is supply, doesn't matter. Is a furnace airtight? No. So if the people breathe the air you just connected, it's a thermal barrier. Whether you're required, and I want you guys to require what you're comfortable with. I'm not saying change what you do, not by any stretch. What I'm saying is, if the people breathe that air, you either have to have a way to turn the air off, which would be a life safety damper, or you have to coat it. It's that simple. There's no in between. When you get in between, it's a contractor trying to convince you something different, or a report that is written very poorly on purpose. So that's where the code sits. So crawl spaces, obviously I made this and I kind of got way ahead, but crawl spaces grow things. You know, you look at whether it's vented or unvented, they grow things. And so, you know, indoor air quality, we look at rot, degradation. You know, if it's open cell, that's not going to stop any of this. That's just putting a sponge in there. So you put open cell in a crawl space, you've just thrown in a sponge. That definitely doesn't insulate. So, you know, you got to look at that. This talks about unvented crawl space. Exposed is covered with a class 1 vapor retarder. Continuous operated mechanical exhaust ventilation rate equal to 1 cubic foot per minute for each 50 square feet. That's what Meritage went on. So all they did was exhaust in there, and everybody said, well, that's fine. When we were talking during the break, I did admit to a guy, what happens when the homeowner decides somewhere down the road that their bills are too high and they caulk the molding to the floor? Did I not just violate Meritage's design? So, you know, again, it's up to you guys. I'm not saying that you have to do one thing or the other, but conditioned supply delivered at a rate of 50. Those are the rules. I can do either or. I am a fan of both. Now, I came from, you know, I wasn't a good child, so in the summer I was not allowed to be at home. I had to be with my big brother doing heating and air. And I would much prefer a system that has both sides. I don't think you dry out air by just shoving it in a different container. So, anyway, plenum in existing structures complying with, well, if that space is a plenum or anything being used as a plenum, like a drop ceiling, every plenum has to have a cover. So, you want to look at that? Wow. I talked about the Santa Fe. Somebody came up and said during the break, you know, I don't want them putting in a plug-in dehumidifier from Walmart. I absolutely agree. What if the crawl space floods? For heaven's sakes, no. Something professionally installed, bolted, you know, in place, up above. Yeah, no, that's why I said this starts at $1,000. We don't get to go to Walmart and that gets us to pass code. So, but supply, you know, 1 CFM for 50, return, balanced, only negative pressure. Again, life safety, dehumidification, those are really our two choices. That's what it boils down to. Either we opened it or we didn't. So, exceptions, you know, insulation placed between 2 layers of non-combustible material. How many people are going down there with like Kingspan panels? Nobody. So that's where we're sitting. Insulation installed between a finished floor and solid decking without intervening airspace shall be allowed to have a flame spread index of not more than 200. That's pretty high flame spread. Still a smoke development of 450. So for ventilation, it's where there's no heat producing appliances. So if I've conditioned a crawl space that has an 80 or an 84 or anything less than a 90% efficiency furnace, what do I need to do? Bring in outdoor air. Absolutely. I got to build a room around it. How many of your contractors are doing that today? You know, that's the thing. Open combustion's open combustion. So the other way is bring in outdoor air, throw up a thermal barrier, you're done. I'm okay with that. But it's got to be able to breathe. So reduced level of protection is also available in situation where service of utilities is not an issue. Not if you opened it up. If there's no mechanical down there and you've opened it up to the living space, there is no limited amount of protection available. So we'll just keep it to that. Here you can see our friends
heading to their favorite place, wood. So we need the inspection strip. Got to have that. So, we look at codes and code officials. Guys, really a lot of this, when we look at the codes, this really started back around the turn of the century when we let San Francisco and Chicago burn to the ground. Insurance companies, they filed bankruptcy, and the people got nothing. And the insurance companies said basically, you know what, we can't recover from a town that burns to the ground. So we need codes, and they lobbied Congress, and that's what they got. Well, now we're getting into energy codes and things like that, even green building codes, but you guys can adopt or take out whatever you want. Well, that kind of happened a lot with the 2012. The builders threw a fit. They didn't want to put insulation on the outside, so they took that part out and kept the air changes and things like that. But there's two ways to meet the code. There's prescriptive and performance. Well, even when we look at that, there's huge changes we're making. You look at the 2012, it was a 30% improvement on the code, all in one shot. And there was reasons behind it, but the changes included mandatory air infiltration testing. Last year, 1/2 of all houses built in the United States were air tested. And it was actually 248,000. I know that's not half. I want to explain this because, and I'm going to back up a little bit. If I'm a HERS rater and I'm working for Pulte, that's my main client. If we go out on house number 2187, that's 2,187 square feet, and it passes, I only test 1 out of 7. But when we fail, I test every one of them. And after 10 of them, if I'm comfortable, we'll go back to 1 and 7. Does that make sense to everyone? So when you go out on a job site and you find a guy that used latex instead of intumescent coating, I would think it would be very fair for you guys to start testing every one of them on them. And then when they pass after a while, then go back to testing once in a while. I really do believe in destructive testing, like you said, Dwight. I'm into it. So anyway, so 3 air changes where we're at, 5 if you're in Florida and Houston, because they eat a lot of beans. But sorry, I couldn't pass that one up. I thought of it. Anyway, so increased levels of insulation. We did eliminate some duplications. 2015, we actually took out the exemption for hysterical buildings, which are, those 1880 Sears Craftsman homes that somebody buys for $1 million and puts another $1 million in to make them airtight. But here's why we look at thermal bridging. Here you've got a house where an employee of a foam company borrowed half a set of foam. I say that loosely. The picture's mine now, but anyway, he borrowed half a set of foam. His wife on that side of the house would not let him rip down the cathedralized ceiling. She said, there ain't no way. The other side, what he did was sprayed in between the rafters because he only had half a set of foam. So what you can see on that side is the energy doing exactly what it does, melting the snow beautifully. And on this side, you can see every rafter. Well, you would think that the greatest insulation job you could ever have would be to take a 2x6 building and just fill the walls full of foam, closed cell foam, and shave it off. Josh, you're a foamer. How often would you like to do a full fill and shave closed cell job? Never? Yeah, I'd rather have certain body parts removed. It's impossible. But if you happen to be the owner of a very large insulation distribution company, you just might do that. And when you do in Minnesota, don't you tell Chris I showed you his house. You find out what thermal bridging is. Here we have a house that was designed to never use energy, and we can see every 2x6 on it. This would have been better had we built it out of 2x4s and put 1 inch of foam board on the outside. Literally, it would outperform the structure they got. So that's what thermal bridging is, and the code's been looking at that. So we've made it where zones 3 and higher, you cannot build with 2x4s without putting insulation on the outside. That's basically where it's at.
This will give you better performance because you've got continuous on the outside and therefore you don't have the thermal bridging. But the 2012 code, we thought everybody was going to adopt it. 10 states did, and then it kind of hit a screeching halt because the 2015 code came out. And the 2015 eliminated the blanket exception, like I said, but also it allowed the ERI, the Energy Rating Index, which said, look, we just want to make sure you're doing the right thing. That's all. If you're doing the right thing and the building works, great. Otherwise, do what it says. So it changed some R value testing and things like that. Different requirements. If there's a combustion closet in the attic, remember we've talked about that a couple of times today. If I have to put walls around a unit in the attic, I need to insulate those walls. So they're supposed to be insulated to the same as the walls on the house. But the ERI score, if I go 100% of the 2006 code, that's a number 100. 100% of the 2009 would be an 85. The 2012 would be a 70. As I said before, the numbers they threw in the 2015 code were between 51 and 55. They literally wanted a house to use half the energy it did in 2006. So they tightened the screws pretty tight. So ResNet started doing training for code officials, things like that, giving away brochures, giving away yard signs, and all this to promote the ERI. We've now got California going for net zero by 2020. And I was in Texas. I'm always one of those, not in my backyard, we'll secede, that kind of attitude. And so, we figured never. Well, then the Department of Energy said, oh no, we want 84% of all new construction net zero by 2018. Now, I'm not sure if all of you know what net zero means. All it means is basically, if I go after it, I need the house to make as much energy as it uses. That's it. So I could just throw on a massive amount of solar panels and let it leak like mad. Either way, I'm not using energy. So then they want net zero ready, but to this point, we have 150 local and state jurisdictions that have picked up the 2012 code, or the 2015, sorry. Now, it's a stretch code. And what that means is, as long as, if you want to jump in, I could say everyone in this room has a master's degree. As long as you'll take 12 hours this year, and next year, and the next, and the next, and at the end of 5 years, when you've got your 60 hours, you still have a master's degree. If at any time during that you don't raise the bar the next year, you're out. You no longer comply. Well, that's what this was. It was designed to get people in, or get builders in, and then tighten the screws each year, so to speak. So we had a bunch jump in. You'll find a lot of states jumped into the stretch code, but it wasn't this way years ago. The reason we have focus now, if you look at, we didn't adopt the energy code till 75, and that was because of the oil embargo. We had, lines of vehicles around, the Exxon station, and so it was a good thing they had Slurpees back then. But anyway, 2009, June of 2009, we had a guy go before Congress and have a talk, and all of a sudden they put us in cap and trade. That meant that we had to report our energy usage to the federal government, which reported it to other nations. That changed everything. All of a sudden, the government was jumping into the energy codes and compliance. If I took you from 1975 to 2006, we did not raise the efficiency of a building 10%. All of a sudden, we've taken it way up. Because all we used to have, when this thing first came out, all we had was, this is literally off of a VCR. You guys remember those? I had one, we had a yellow sticker on it that told us how much energy it used. Well, we have an aging power grid. We share power now. Power is becoming controlled globally, not locally. And so you guys are having to sign off on acoustics, air barriers, things like that. Why would you guys sign off on acoustics on a house? Because everybody thinks they need to work from home. I'll give you one more thing. I like the idea. We will never put foam on the attic floor and on the ceiling. But I love the idea of when you foam an attic, you go back and you blow a little bit of cellulose, a little bit of fiberglass, I don't care what, but you blow something over the master bedroom and the bathroom closest to the kitchen. And when I explain it to a homeowner, I tell them, look, it's how fast you want to educate your children. Because when I move the sound layer from here to here, you can hear the master bedroom in the kitchen. So, anyway. Some of you are nasty. Quit that. So, anyway. You guys have to sign off on this stuff, and up to 7 trades can be touching an envelope. On commercial buildings in the 2015 code, we had to add building commissioning. The reason we did is almost embarrassing. Because when some guy buys a 10-story building and spends $15 million on it, the day he goes to get a CO, he gets hit with a 10% change order because none of the systems communicate or work. We've got dampers that are auto dampers that the HVAC guy didn't get to hook up and the electrician refused to. We've got every room has to have a light sensor to know when someone's in there, pressure sensors to turn on equipment. Literally, we've made buildings that don't work. And when 7 trades touch the envelope, what we've found is now we're starting to build a new trade, which will probably happen over the next 10 years, which is a building enclosure specialist. Because you guys don't need to deal with 7 trades on an envelope and try and be a babysitter for every one of them all the way through the project. So this commissioner actually has to be there from the day of design all the way through construction and the first 5 years of operation. And when we go and have our big meeting up in Massachusetts each year, I'm talking to these guys and they said, you would not believe the number of people that call me in after the building is built and offer me all kinds of money to sign off on this crap when I've never seen any of it happen. And he said, I won't do it. And he wants to name his competitors to me that will. I'm like, I'm not the police. So anyway, so that's kind of where things have gone. Now we've got, ResNet. They're now allowed to be, they're a voting member on the board of the ICC. They are allowed to act as local code officials in terms of energy inspections. And so you guys can use them. But as I said, Texas, I thought we would secede. Well, I kept saying this would never happen where I live. And it's funny, because when you look at the goal of the DOE and the people that are doing this, which really is ResNet, which you guys may think that's just HERS raiders, the blower door guys running around being do-gooders. ResNet is actually the mortgage banking group. That's who ResNet is. And so they're getting these codes changed for reasons. And they want the value of a building to change. Well, if you look at Texas, during the last administration, 20% of the homes built in the United States were built in one state. And in the middle of the night, literally, if you look at this, June 6, 2015, Greg Abbott, he'd just been a governor less than a month. None of us knew this. Greg Abbott signed the 2015 code into law. Well, if you're going to take over the high school, you just kick the biggest guy's butt first. That's the easiest way to do it. So they came in and they passed the 2015 code. I found out about it in October. February 6th, I think it was, I was talking to the Fort Worth Home Builders Association. How many builders knew we were going to be on the 2015 code September 1st? Anyone got a guess? 0. No one had been told. And they had till September 1st to figure out how to put insulation on the outside of a building. I now have 5 builders in downtown Dallas, or in central Dallas, that are actually putting insulation on the outside. The others are all going performance. So they're going with the ERI. Now, anyway, there are 14 new fields in the MLS. When you go to buy a house, it will talk about the energy package. It'll talk about the envelope. It'll talk about the lighting package. That's now in the MLS. And you look at this. This is whether it's a house, whether it's a commercial building. They are going to start driving the value of buildings or structures based on the energy package and the envelope and the loan qualification. For all of us that have bought houses, remember we just go up against PITI? Principal and interest, taxes and insurance. What's your DTI? Your debt to income ratio against PITI. Not anymore. Because now, here's how they got this through Congress. They said, oh no, it's got to be PITI ERI. The reason why? If I go by Patriot Stadium in, well, no, that's not a dome. If I go by the dome in Houston, I have to be able to afford the power bill, don't I? The loan company should be concerned about that. So any structure I go by, commercial or a house or otherwise, I've got to be able to afford the energy bill. So therefore, they want to know what it is. The mortgage company has the right to ask that, or at least they believe they do. So back to this. We have two ways to meet the code. We can go prescriptive, which, and I'm giving you guys the way I teach contractors. I understand you know this. I just want you to know, one, what we teach them. So they can do exactly what it says, and I tell them, think of a doctor. If he writes you take one pill every 4 hours, that's what you do. If the code says R100, that's what you do. Or you go performance. Well, but I need this document to show a code official to do this. I said, look, you can pay a rater, you can learn it yourself, you can go prove to them you're doing this right, or you can do it. Either way, doesn't matter to me, but you got to do it. So, grade 1 insulation. How many bat jobs do you guys see that look like that? It's sad that you laugh, but it's true. So, you know, because they don't. They tend to look like this or like this, you know, because who builds our houses? It's young guys in a hurry. That's who it is. So, you know, that's who's building our houses and our buildings. It's young guys in a hurry. So stapled, compressed, that loses value. Two pieces hung side by side, that loses value. Gaps at the floor. You look at this, wait till you see how that performs. Have you guys ever seen infrared images? Do you look at them much? Check this out. So that's our wall, right there. Every stud is outperforming the insulation, and studs have an R value of 1 per inch. That's how it's performing. So you look at this. This is direct from where I kind of got my teeth cut, but the BPI, Building Performance, Building Analyst Guide. This is your engineering report. And it says, yep, cellulose is supposed to be 3.7, fiberglass is supposed to be 3.0 with an asterisk. Okay, rock wool 3.0. Here we've got low density foam 3.7, urethane 6.0. But if ours is good, remember that very first one, grade 1 insulation? That 3 is actually 2.5 per inch. At 2 inches, I got an R5. 3.5, yeah, I'm kind of around an R10 when I've done them right. Fair, which sometimes you guys see fair, not in that last picture, but you see it most of the time. That is 1.8 per inch. That's why that last picture was what it was. Poorly insulated fiberglass bats is actually an R value of 0.7 per inch. So when we look at performance, this is a heat flow reduction chart. At 1 inch, you can see obviously, you know, what we're doing. I've got 83% blocked, but here's where I land. Between 94 and 95, 3 to 3.5 inches of closed cell foam, I have blocked 94 to 95% of all thermal transfer. Now I can tell a customer I want them to buy 6 inches, but at 6 inches, they've only gained 2%. Effectively, I'm ripping them off. That's why we don't make freezers with more insulation. It really is about how much insulation does a Yeti cup have? It's 0. It's the air barrier that counts. So, you know, nobody's really inspecting that. Without a blower door test, I don't know. I use the adage all the time. If you're not testing, you're guessing. If you can't measure it, I don't believe it. It's that simple. So that's why I'm a performance guy. Either give me what the code says or go prove it. That's where I'm at. I don't want anything in between. Take a look at that wall. Could you effectively insulate that with fiberglass? Any one of them in the room? No. I can't do that. That's just somebody went insane. So, but that's how it wound up in the end. And that works. I'll get an air barrier out of that, at least pretty close. There was a lot of stuff in that wall. So, what about this? You know, this is where I see contractors go broke. They're like, they walk through and they bid it by square footage, and then they wind up doing 2 stories of scaffolding, and they're paying 3 guys, one to shimmy the fiberglass up the scaffolding, one to sit on the bottom and cut it, and one to sit up there and shove it in. And none of that was bid right. Anyway, we don't need to go there. Or I can do that. So I want to talk about California. I know we're not there, believe me, but I want to. Yes. I do thank God for that. So, anyway, one thing to understand about them, they make building as hard as possible. And California, the bare minimum code in San Diego, where there's not even a reason for insulation, their minimum in order to pull a building permit is R38 plus a radiant barrier. You have to have both. That's the bare minimum. Where all the lawsuits come from, and this, I used to have to get involved in it and fly out there, they offer up to $50,000 in what they call solar energy rebates that don't require solar. All they require is that you are 30% above National Building Code. So you have to be 15% above Title 24. Title 24 is the bare minimum to get a building permit. That's 15% above. If I'm 15% above Title 24, I get money. When people miss their $50,000 rebate, guess who the next call is? An attorney. All the time. So, let's look at what they did. They actually did an engineering study and they went through all of the dynamics and they said, okay, here's our bare minimum. The base case is a vented attic, radiant barrier, R38. That gives us an average of 10.5% in efficiency for what they're trying to do. They want high performance attics. Then, if you want money, oh, now you need an R13 wired to the roof deck and R38 on the floor. It's got to be an R51 and insulation in 2 places. If I don't want money, in order to compete with an R38 and radiant barrier, you can do R22 of spray foam. But you have to be under 3 air changes. That's it. Mechanical and conditioned space, R22 of spray foam, 3 air changes. In order to get money, now you have to be an R28 in spray foam, and that'll give you a 21% above code. So that's one of their documents. Alabama made it even simpler. Alabama goes, well, here's our code. You can throw in an R30 or an R20. We're not telling you why. I was like, well, that's really good. That's helpful. Gee. So I'm not sure about that one. And I've heard it a lot, and I've had guys in Texas say, well, why can't we do R30? I said, are you in Alabama? You know, Alabama's a 3. You're in a 4 to a 5 in Dallas, and you're asking that question. No. So, you know, it's what you guys want to do. I will tell you that now I wouldn't mind if you guys allowed one thing from another state, and that's what's called IC3. I do believe that, do you all know what REM rate is? Of course you do. REM rate's your HERS rater path. Okay, here's my issue. They are making that so expensive now that they have to add another. 2017, they just added one more compliance person to make it one more expense, which nobody ever needed. Show me the blower door numbers, tell me what the fenestrations are, show me the, you know, show me the right soft package. What's my manual J, S, and D? That would be great. Well, IC3 was from the University of Texas, and so it only goes to zone 5. Well, you guys are within zones 1 through 5. It's free. 4, yeah. So you guys, as long as they're putting down that they're somewhere between Dallas and Austin, it would be your code. They can literally put everything in there and it will print out an entire ERI number for nothing. It's a free program. It's the only free one there is. But it'll still tell you whether or not you pass the 2015 or 2018 codes and give you an actual number of the performance of the structure. Ecotrope is another rating software. They're out of Florida. Energy Gauge is from the University of Florida, and it's $250 to $300 a year. It does the manual J's as well. My issue is the only thing with Energy Gauge is if you don't understand what the guy handed you, you get just as much service as you would expect to get from the University of Florida. You might get a call back in a month. So, you know, that's not what I would call an optimum. Otherwise, you've got REM rate, which, you know, HERS raters, you're going to pay for each rating. They pay for some guy to come out and inspect their ratings. There are more of these in development. I believe RightSoft is making Right Gauge now. It's not released yet, but they're making it. And then even simpler than all of this, there is one new compliance path. I was talking about it before we even started today. And it's funny, I heard a guy describe it 2 days ago in a way that I didn't think I could do better. When I said, it's unbelievably simple, it is so unreal, it's bulletproof. And I explained what it was, and the guy goes, oh yeah, I'd expect that from a bunch of pot smokers. So what it is Aspen, Colorado. They got tired of all of this, and they said, quite simply, you prove to us that you can be at 1,000 square feet per ton and you pass. How incredibly simple is that? Because to understand, to get to 1,000 square feet per ton, I have to capitalize on solar gain in the winter. I have to prevent solar gain by using shading in the summer. I can't get there without those two. But then I still have to be under 3 air changes. I still have to have the right equipment. All of my fenestrations have to be dead on perfect. My alliance to the sun, or my orientation to the sun, has to be dead on. It's near impossible. So Aspen just said, well, there's the bar. Go meet it. And then they're all going back to their drawing board. So anyway, the part of the code where we do allow closed attic assemblies. It's 806.4. And 806.4, when it came out, said you have to have air impermeable insulation. So you have to seal the attic. Let me ask you this, on a retrofit, since the rule is you have to seal the attic, if somebody's going to throw on an addition and retrofit an attic and you go out and look at it, and you still see cellulose all over that attic floor, do you think they got a good seal when they brought that down to the edge? Not a chance. So anyway, but it's got to be sealed, it's got to be tested. You go through this talks about, the different zones and what they want in the zones. Suffice to say, basically, you've got to, I'll show you a chart. If you guys go to the SPFA website, which is the spray foam website, document 147 will tell you how much spray foam they need on the roof deck in order to avoid the thermal transfer, the ice damming, and things like that. I'll show you a picture of it later, but here's why we didn't allow air impermeable insulation in the beginning. They tried it, and it rotted out roof decks because the moisture was trapped. Well, the issue is now you have the unvented attic space. It's directly under the roof sheathing. This is for condensation control. Even if I put rigid board up there, I need a minimum of R20 against the roof deck. Otherwise, I'm going to have problems. So that is the bare minimum, regardless of the blower door number. Well, with fiberglass and the other air permeable insulations, they want the standard R38. They are putting it directly to the roof deck, but they are using a smart membrane. They have to put on a ridge vent, and up at the ridge, you have to have vapor permeable membrane. If the moisture can't get out, we're going to rot the attic. So these require it. It also wants 50 CFM of supply air. We talked about that. That means thermal barrier for spray foam, air permeable in zones 4, 5, and 6 they're starting to do, but they figured this out up in Alaska, where they had SIPS panels laying against each other. As soon as the house moved, the whole thing started to rot, because the moisture was going up. So when those SIPS panels broke and the air would go up through it, it rotted out all that sheathing. Well, it rotted it out 3 foot each side. So I talked about Dr. Joe earlier. He had this engineer that said, you got to go 6 foot down this side and 6 foot down that side with your membrane. Here's all my calculations. And Dr. Joe, the ASHRAE fellow guy, he says, no, you don't. He said, I'll prove it to you. The guy says, nope, I've done all the engineering calculations. And he said, well, I'm sure your math is wrong. They fought about this for about a month, and finally they get on a job site, and the guy says to him, he goes, you know what? My calculations were wrong. I had to do 3 foot each side. And Joe said, I always knew, and I never did any math. The guy said, what'd you do? He said, I was up in Alaska, and the rot was 3 foot to each side. It's like, duh. So anyway, that's how they took care the There's no such thing as rust on top of a water heater. That is corrosion. That is from acid coming back down the flue and rotting that out. So carbon monoxide alarms, I know that when somebody pulls a permit, they've got to put it in. What I want to let you guys know is I don't care if it's the $7 one in the 10-pack from Home Don't Know or $100 one. It makes no difference. They're the same. They have a timer that goes so many seconds and resets whenever it doesn't breathe the carbon monoxide. It's over $125 to get something that will go off immediately at 35 ppm. So I just want them to put one in. And I don't want it on the ceiling. I don't want it on the floor. I'd prefer it to be at sleeping height. This is just me. Because carbon monoxide moves. It does not sit at one level. It doesn't necessarily rise or necessarily fall. I want it at sleeping height where it would build up. But we do need to make sure they're putting them in, at least where there's appliances that would cause that. Now, I mentioned it earlier, spray foam at 1 inch is an air barrier, but we tested 50 houses that were done with spray foam. Their air changes were between 0.6 and 1.6. So they averaged 1.1 air changes per hour. This was for Meritage homes. And so this is our average is 1.1 air changes. That's pretty darn tight. 0.6 is getting down to passive house. When we talk about CPVC, foam does not wreck CPVC. What does happen though is the last thing that's usually done on that pipe is they will bring it up and test its abilities. So they'll pressurize the pipe. Well, then what happens is they leave. We have Johnny and his foam truck show up, and it's 40 degrees in the morning. And open cell foam hits 200 degrees in 7 seconds. So he sprays over that pipe, and what's the pipe do? It expands, yeah. And that end of that pipe just pops right off. Does he know that happened? Yeah, not until we go put water in it after the sheetrock's up. So you guys get the idea. They need to be making absolutely certain, even where it goes through walls and things like that, that they let the pressure out. If they do get spray foam on the CPVC and somebody loses their mind, I've had Spear lose their mind in downtown Denver. They manufacture one of the pipes. And they said, well, the foam's got to come off the pipe. It was like, well, you just added plastic to plastic. It's got to come off. The guy went in there with solvent and cleaned it off. Yep, replaced the pipe. So it's so much so, this pipe is very temperamental. The largest lawsuit I've seen on CPVC pipe was from an installer putting it in while eating a peanut butter sandwich. And it was a casino in Tahoe. And the peanut butter, literally the oils in the peanut butter wrecked the pipe. And after the casino was all put together, they fired up that system and it was 6 figures worth of damage. So, and so I've got a letter from an engineering company, not that that matters. It's up to you guys whether or not you make them take it out. I tell them don't spray the pipe. It's that simple. Just make it easy. It is more than fine. We've done studies on PEX. We've done studies on PVC, even the new Green Rigid, the brand new one that they've got out now. We've done studies on all of that. And it's really just adding plastic to plastic. My issue really is the closed cell foams. If they are spraying greater than 2 inches, you know the low voltage wiring in the walls? That stuff, some of that jacketing's out of China. And I'll tell you what, we used to have more trouble when guys would not staple that wiring in, the foamer wouldn't go and check everywhere, and then they would spray the wall and it would push that wiring out and they'd come by with their shaver. What happens to the low voltage wiring? Or when they'd use closed cell and they'd spray 3 inches, even though we'd told them never more than 2, never more than 2, never more than 2. 3 inches, I can actually build a temperature well in excess of 300 degrees. And they would have that jacket wear off or melt off, and the 2 wires would short out. Well, when the security system doesn't work, what wall do you take apart? You guys get the idea. It's really kind of painful. So again, chimneys, IC lights, flex duct. Around chimneys, guys, I want to see pink foam. I don't care if it's triple wall pipe. I really don't. I don't know what's going to happen in the future. If they just moved in and they decided to burn every U-Haul box in the wood stove and got it up to 700 degrees. No, I want pink foam, 3 inches. I don't want regular foam up against chimneys and pipes. We talked about can lights. I like an R11 bat. I want it to breathe. I want the pucks for the LEDs to breathe as well. So I'm not concerned about overspray. Again, one more thing on this. I will tell you we've done a lot of side-by-sides. These happen to be for Habitat for Humanity. You can see here was the data. We've got a foam house and a fiberglass house. Funny part is, this was before we put in the humidistat. This was after we put it in. And I'll get back to humidistats in a minute. But so the fiberglass house, here you can see the kilowatts that we used. So our total kilowatt hours was 2373 versus 778. Side by side, same model, same orientation to the sun, same street. It's incredible the way that it works when we stop convective looping and convective bypass. This was a study done by the city of San Antonio. They didn't even tell us. I was like, why not? And it's funny, it was Dr. Valerie von Schramm with the energy company. She was with CPS. I said, why didn't you tell us? She said, you'd have done everything you could to corrupt the study. I said, well, maybe. But what they did, they built their own houses. And so they built 3 houses, all facing the sun, same direction. They did 1 all fiberglass, 1 foam roof fiberglass walls, and then all foam. And you'll find, here's your kilowatt hours for the all fiberglass was 4841. Foam roof, 2300. All foam, 1293. And so then the city of San Antonio and Austin just started giving builders $1,500 per house in order to cover the cost. And I'll tell you why that is. For an energy company, this is extremely selfish. I know you guys probably think they're do-good people. It's profit. What happens? The federal government sets a rate. They say, okay, you can charge X for grid and X for what you buy, and then you get your margin. Well, that 5-year window, I'm allowed 1/2 of my kilowatt hour charge to be grid cost. So there's not much money I'm going to offer for free in the town of Nashville. You go 100 miles out, I don't want to build grid. It's very expensive out there. So I'm going to offer a lot of money out there for free, because every dollar you save me in energy 100 miles out, I'll give you dollar for dollar. You save me $1,500 that year, I'll give you $1,500. Because for 4 years, I'm keeping the grid cost money. That's what it is. So, and it allows, it does a lot of things for the power company as well. But anyway, so this was on a school, and the funny part of this was, this can be done really right, and it can be done really, really, really wrong. I've seen both. Really, really, really wrong was in North Carolina. But what we did, we went and did schools, and we would take out the HVAC, we would change the size. The envelope was actually $63,000 more to do it in foam. What we did was we foamed the first layer of block, and then they put another layer of block on the outside. The pretty block on the outside, we foamed the cinder block on the inside. It lowered the cost of the HVAC $486,000. This building was actually $400,000 less to do with spray foam than it was with fiberglass. But the killer part of this, Dave Lauren with Banwell Architects, he said it great. He said, these schools were less than 10 cents per square foot for heating, while the others were 50 cents a square foot. We cut it by 80%. So what the deal is, all we did was we made the block thermal mass. So the kids heated the school. Well, we did the same thing in North Carolina, and that didn't go so well. Because what they did was they left a bulldozer to put in a potted plant. In other words, they left a big old mechanical system that would turn on, and about 60 seconds later it would shut off. We never removed any moisture from the school. They were throwing books away by the thousand. The kids couldn't get comfortable. It was just dripping all the time because the system was way oversized. You had to severely downsize the mechanical. So now we're going to go into building science. Definitely my favorite subject out of anything that we could possibly do today. Building science is really, it's obviously what makes all this work. And so when we get into building science, we've got to look at sizing of mechanical, how a mechanical system actually works, things like that. So we look at the thermal envelope. The thermal envelope separates the inside from the outside. It's got two parts, your air barrier and your thermal barrier, but as we look at this, it's got to be continuous. Would you guys say that foam job is continuous? Definitely not. This is a really poor job. What about this one? I say this is a brilliant code official. No, those people are not in spray foam anymore. We convinced them to sell their rig. But this code official knew that it had to be at least 3 inches to be an air barrier, or 2.5. And so he let that fly, but just imagine what these spots look like. All they had was some very expensive 286 interior board, and he said, well, you can use that. And you had fire-rated foam, and he said, well, you can use that, but you're going to fix this. It's going to be done right. And he made him come back and do this. So good for him, but 3 main functions of a building, obviously we can't let it fall down and kill people, and then if it's not pretty, no one will buy it. So finish is next. Then the control layers, which control movement of things in and out. So the drain plane is definitely more important than the air barrier. No one calls at 3 in the morning and says there's air leaking in my house. They might call at 3 a.m. if there's water coming in. So you get the idea. So vapor control, then the air barrier, and then the insulation. So there's 4 control layers really in one application when we foam the outside of a building. So we are seeing a lot of exterior foam application now, where we're just doing all 4 layers in one shot. Excuse me. So challenges to this: conduction, radiation, and convection, which are our thermal transfer, and then air leakage, air intrusion, and moisture movement. So when we look at conduction, best way I can explain it, it's how fast heat transfers through, but when I'm talking to a homeowner, it's quite simply, plastic is not what makes foam work. If I poured boiling water in this bottle and handed it to you, it would not be comfortable. I pour boiling water in glass, it would not be comfortable. It is the trapped air. That's the only thing really doing any work here. So I explained that, and then we talked about thermal bridging, but thermal bridging can be 27% of a wall area. So radiation is just when the sun hits the building, it comes through, it'll turn to conduction, then it can actually turn back to radiation. A cool way to explain radiation to your kids is when you get real close to a concrete wall with your cheek, that's when you realize what radiation is. Heat moves, cold does not. So when you feel that cool breeze against your skin because you're so close to that concrete wall, what you're feeling is concrete's a heat sink. It is pulling thermal energy off your body so fast you feel the air come in to replace it. That happens in our houses. Convection is the fastest form of thermal transfer. It's a natural convection by air, but this is what it creates. You got air going in at the bottom and going out at the top. And that's really why California's #1 thing and why they're going to is closed attics. They want something, a lid put on top of the structure. If you didn't have mechanical up there, I'd just spray the floor. I don't need to add all this space. I just do it because the mechanical's up there. That's it. So on air leakage, stack effect is always our #1 issue because it's 24/7. Fan effect is really third, unless, because wind effect's pretty good, but it takes a lot of wind, pressure on one side of the house creating vacuum on the other to draw energy out. But how many of you guys are seeing kitchens now with fans that are just beyond reasonability? Yeah. So we're going to put a lid on a house, we're going to tighten it up, and then we're going to throw a, Chevy 350 with a hood on it in the kitchen and expect it to work. It creates a lot of vacuum on the building materials. So according to the DOE, the Department of Energy says 40% of all energy loss is due to air infiltration. Well, it used to be. Leaky buildings work great. I said that earlier. Some leak more than 40%. Our commercial buildings are in pretty sad shape, to be honest with you. When you look at how bad a lot of them leak, they're pretty bad, but poorly sealed buildings, they do not perform. They perform horribly. So as we get into this, you start seeing some of this, you're going to get some rot. But then you look at these, look at how bad most of our commercial buildings are. Now my house, when we tested it, had 20 air changes per hour. Code says I should have 3. It's pretty bad. So I had a lot. But some buildings need more air. Let's be clear. One thing I don't want you allowing, and I know it's a funny slide, but think of it like this. You're going to see at some point, somebody's going to go and foam. My grandfather started this printing company, 1927. I inherited the building. I don't like the energy bill. I got a foamer, and he's going to come in and foam it. Is that necessarily a good idea? I got acetone, MEK. The point is, if we're going to air seal that, I would never allow a commercial building to be air sealed that does not have mechanical ventilation, period. That is rule number 1. We walk away. If there's no mechanical ventilation, you don't seal it. So reduce air infiltration, ventilate correctly. Build it tight, ventilate right. It's that simple. So we need to know the damaging airflow directions. Obviously in the winter, it's trying to get out. Heat moves, cold doesn't. In the summer, it's trying to get in. So, air sealing gives us some control over that, but we've got to look at the way moisture moves. We all know when the river floods. That's bulk water. But air and diffusion, they create more of this than anything else for indoor air quality. So air will move 100 times as much moisture than diffusion. So I'll show you, this was done up in Canada. They showed a sheet of sheetrock, unpainted, will wick 1/3 of a quart of water over a season. A 1-inch hole, 30 quarts, 100 times as much. And it gets worse. As we look at this, a hole straight in, like I said before, I don't care if you punch a hole straight through the building. We'll talk about Disney. Air traveling through building materials. When I have a leak here or a leak here that goes down through, this is what I get. Because the air changes temperature and it rots things along the way. It's a huge concern. This building right here, Cinderella's Castle. Disney was going to sue the pants off of a contractor because they'd rotted out one entire side of Cinderella's Castle, and it was a 1-inch hole. What it was a 1/16 of an inch crack, 1 foot long. Disney engineers actually calculated the water that came through. That crack was bringing in 228 gallons of water into that wall assembly per year. Rotted out the entire side of the structure. That was expensive. So that's why I said, this is where a lot of the lawsuits are. I'll give you one on a Miami high-rise. This is probably the most hilarious commercial retrofit I've heard of. This guy goes down to Miami. I know a guy, he air sealed 50 million square feet last year. And he's good. He's an incredible building scientist. But he gets down to Miami, and it's a 40-story building, and he's there talking to the management company in the lobby. And they're chatting away, and it starts to rain. And next thing he knows is the ceiling tiles are starting to drip. And he's like, okay, well, I understand what's happening here. But then he started to laugh because he watched a guy wheeling a cart. There was one guy wheeling a cart and another guy. There was 2 carts that came in of ceiling tiles, brand new, still in the boxes. And he said, what are you doing? And they said, well, every time it rains, there must be a leak in the roof because water's coming down and it's hitting the ceiling tiles and they rot out and fall out, and we have to put in new ones. And he said, how long have you been doing this? They said, 20 years. He's like, you're kidding me. Now think about this, guys. If you're a millionaire, South Beach, can any of us in this room afford a condominium on South Beach in a 40-story high-rise? Okay, I didn't think so. I couldn't. If there was water coming into your $4 million condo, would you not throw a fit? That water was not coming from the roof. What it was the second floor had the concrete deck, which they were keeping the AC down. There was a couple of restaurants up there. So what do you have with restaurants? Coolers. This concrete deck would sit there, and every time it rained, it would just collect water on there. And about 25 minutes later, what do we got? We're raining inside. So he knew there's got to be some serious airflow. Well, so he goes up to the roof, because our rule is you always start at the top. Why would I tell you that closing an attic is important? Because on a high rise, putting a lid on the chimney is massive. It's the number one place we go. What happens? He goes to the roof, and he's looking at all this ocean air rot around this big hole going out to the roof where there was a door 20 years ago. He said, I got to tell you, Ken, I've never made $50,000 for installing a door, but that was one of the best days of my life. I was like, well, you fixed the building. But that's what he did. He went in and he put on a door and stopped the stack effect. Now, he filled a few holes, and he was exaggerating. He was there a week. But you understand what we're getting at. So vapor flow is really big in building materials, and I told you, foam's a vapor retarder at 1 inch. Don't play Kansas City and Nashville, please. If you're going to let a guy put 1 inch of foam on something and cover it with fiberglass, just kind of try and make sure it's a really warm year. I prefer 1.5 inches. In Texas, I'm okay with 1 inch. Here, I'm sort of okay with 1 inch. Kansas City, you really need 2. Because it's going to be 0 degrees for a week. It'll happen again. This wasn't the only year. So make sure you do that. When we put the vapor retarder on the wrong side, we really have problems. So sure you guys have seen this, but have you seen this? So Arizona's in the top 5 in the United States for black mold in the wall. The reason why is the delta T. When we have 170 degrees on this side of the wall, and somebody trying to make 68 on this side of the wall, I got 102 degree delta. So as that air rises in the wall at 170, even though I'm in the desert, when it hits that 68 degree paper on the backside of that sheetrock, it deposits every bit of moisture it's got in it. And then as that moisture builds up, it comes through to the inside. Okay, you guys will never forget Dr. Joe. If you look up Dr. Joe Stiebrick, you'll find out a lot. He got famous by fixing buildings for the government. But this is one of his specific cases, except he did this with Hampton Inn. He told them to quit using vinyl wallpaper. Dr. Joe is not allowed to speak in front of women and children. And you'll figure out why. He's just dry humor all the time. When he went to his first job, he graduated college in 1984. He was living in his parents' basement. Gets a call from the federal government. And they said, hey, the Library of Congress, nobody wants to work in it anymore. The building smells. Can you come fix it? Like anybody that graduated college last week, he only had one answer. Sure. Yeah, of course. Well, they said, how much? It's 1984. He's figuring, well, it's the U.S. government. If I tell them $1,000, they're going to think I don't know what I'm talking about. $10,000 for a day. They go, okay, come on down. He was shocked. So he shows up, he walks into the front of the building, and it's not bad, but the farther back he went, the building smelled more and smelled more and smelled more. And then he opens these doors, and here's a dock in the wintertime with 7 semis all running their engines. He's like, well, I figured this out. I could go home. That was 30 minutes. Yeah, they probably wouldn't call me back. I'd better hang around a while since I've already solved the case. About 10:30, all of a sudden the smell filled the entire building, and it was not good. And he thought, well, what the heck just happened? So he kind of went downstairs and he was inspecting the building. He gets to the basement, and here's 2 doors doing this. Just, they won't even shut. And that's because across the street under Pennsylvania Avenue at the House of Representatives, it was going to be lunchtime. They had just turned on all of the mechanical for the kitchens. So the doors wouldn't close. Well, then he really figured it out. He was like, look, you got a negative pressure building, you got a bunch of trucks, of course the place is having problems. And so Joe, being who he is, he gets an award for what he'd done.
and he goes out to Las Vegas 2 months later. And in Las Vegas, from the stage at one of the casinos, he tells a group of engineers from the whole United States, hey, if you ever wanted to get rid of Congress, all you got to do is back up the truck of sarin gas to the Library of Congress at lunch. You'll gas them all. They all laugh, and 2 weeks later he's at home and he gets a call from the FBI. And they said, is this true? And he didn't answer. So he got asked again. And he said, yes, it is. They said, we've got a contract for 75 buildings we want you to fix. If you ever want to know something and you want to know it for free, I would highly suggest going to the Building Science Corporation website. Because every white paper since 1984, Joe's made so much money. He's been an ASHRAE fellow and helped write the code for 15 years now, but they have done so well that he and Betsy, his wife, decided that every paper, every white paper, every study they had ever done, they would put online for free. And if I go in there and look at metal building roof rot, or I look at standing seam roofs with spray foam and why they don't work, all I got to do is type that in. Up will pop the white paper on it. It's that simple. Anyway, back to this picture. I know that was a long story, but I want you to understand the guy before I tell you his bad joke. So he's talking with Hampton Inns, and he says, you know the problem here. He says, you've got all this heat on one side while you got cold on the other side. He said, you've put vinyl wallpaper up in the sleeping rooms. And they said, yeah, we don't have to repaint the walls. He said, no, you don't understand. You've made a building to screw in with the prophylactic on the wrong side. And they're like, what? And I kid you not, he did this in front of a group of architects in Seattle, and I was like, Joe, we can't bring you anymore. But anyway, here's what's happening. This is a hospital room where they have used a vapor barrier. Why? The laws. The problem is they have not filled that wall and have not insulated the outside, and as the cold surface on the inside is just attracting water 24/7 in that environment, and every one of them rotted out. They literally had to redo over 100 houses in a subdivision in Phoenix because of things like this. So it's all about convective looping. In Europe, they count for it. We don't do this in the United States. So we don't even address convective looping. What I do want to tell you is if you have anyone do hybrid walls in your area, make absolutely certain they are using unfaced material over the top. I don't want a nominal 1 inch, I want an inch plus. That way I don't have spots that make water. But more than that, I don't want a second vapor barrier because this wall can only dry one direction, and that's inside. So make sure you're doing that. Anyway, 1/2 inch or greater thickness on medium density. This is the SPFA guideline. This is 146, which will cover your climate. 147 covers the north, but this is the table from 147, and I would probably have it in your arsenal because if they want to do a hybrid wall in your market, you said you are zone 5, correct? 4. Okay, so you would be 4B and C. Okay, 35% of the wall's R value must be in that spray foam. So what's your wall? 13? 35% of 13 is the minimum I want them getting away with. So this is a direct guide from the SPFA. And that's why I say that. If they want to do it at the roof deck, check this out. Well, if we're at R38, the least you can put up there is 39% or an R15 against the deck. 2 inches against the deck, any less than that will not work. You will have problems at the roof deck. You'll be creating moisture. So, and that's due to night sky cooling. Anyway, these are our challenges when we look at building science. And I've got to hurry through this. There are master's degrees in building science now. So all we're doing is just kind of running through it. But I mentioned this before, we never put foam on the roof and the floor. We don't put foam on the roof and leave faced bats on the floor. I don't even like having insulation across the entire floor because what this is a terrarium. And terrariums grow things.
It's an area that cannot be conditioned. So I don't want to trap moisture. The next thing is, this is the job I was talking about. You think they got a decent air seal? We had a retrofit that went really, really south in Fort Lauderdale, Florida. Everyone that lives on the canal where the yachts are in Fort Lauderdale is broke because they all have attorneys and they like to sue. Anyway, we had a foamer miss a hole the size of a quarter. And it was on the marina side, right against the marina. And as the sun would come up, that side of the house would warm up, the AC unit would go on, and the attic was negative pressure. So about 10 in the morning, this was what was happening. At the same time, they're firing up their boats. This fumes from the diesel carrying the oil with it took 11 months for that oil to go rancid in the attic and make the whole house smell. This was not a remove the foam job, it was a remove the trusses job. Yeah, guess the cost of that one. So anyway, I believe in the wisdom of a good Southern band, Leonard Skinner. Ooh, that smell. Yes. In fact, if you don't get a proper seal, you can get smells, but these are amines. Well, guess what? When A and B come together on spray foam, we make one thing. Amines, and lots of them. So much so that we have to ventilate for 24 hours. We make that many amines. Amines love to find dry material. Would the old cellulose in the attic be dry material? How about the wood? Those amines will permeate everything and they won't come out until next August on the warmest, most humid day. So unfortunately, our amines don't smell like lavender morning. They smell like dead fish and maybe a little bit of lemon zest. I don't know. But anyway, then air changes and old friends. Think about it. That attic, before we came along, probably had 2,000 air changes a day, at least. That's with just a light breeze because it's just vents and open space. I don't care how often the neighbors picked up after their dog. There is dust that gets in the air, and that dust is all collecting in the attic. They may have been afraid of black widows and bug bombed every other week from Monsanto. There may have been a fire at one point. I don't know what happened in that attic previously, but when I take what has never been part of the envelope and all of a sudden I bring it up to temperature and humidity and make it part of the envelope, it might smell. That's my point. So I've got air changes and old friends, my old buddies. How many homeowners want to pay a foamer to suck the fiberglass out of their attic before they foam? You can answer that, Josh. How many are dying to have you do that? 0. I'll tell you exactly how I do it. I look at them because I know they've all been to Google and they've all read things about smells. And I have a sheet of paper. First thing, okay, you'll never respect me after this, but that's okay. I don't sell anymore. But when I did, I would take a 1-gallon fresh Ziploc bag up to the attic. And I would go up there with my dustpan and I would find my little friends and I would carefully fill my 1-gallon Ziploc bag. Let me grab something here. So when I would do this, I would fill it up. You'll get a good example. So I come down to your dining room table, you're both sitting there, and all you see in the top of my baggie is pretty pink fluffy stuff or white fluffy stuff or gray fluffy stuff, whatever. And I'm sitting there saying, you know what? This is what's up in your attic right now. You guys get the idea of what I'm doing. Because when I flip this over, there's going to be so much dust. And anyway, so I say it's real simple. I go through the air changes and all that. And I say the issue with this is, if I'm in control of all of the factors, then I'm in control of the smell. So if you have me go up there and take all that out, then I'm in control of all the factors, and I will guarantee you, because we actually process our product and we ventilate, I will guarantee you this house will never smell. I can guarantee them that. I'm going to make plastic. But if you don't want us to remove this, and then I turn it over and show them my friends. Hopefully I even got a dead friend, I don't know. But I show them that and say, if I'm not in control of all the factors, I can't guarantee you it won't smell. And I've never had a problem having homeowners tell me, yeah, that's coming out whether you do the job or not. So, so again, I'm just telling you guys all the factors. We're off codes. So I want you to understand building science and how I go about what I do. But so I deal with my old friends. I believe in vacuuming it out. Happy customers don't file lawsuits. It's that simple. So proper ventilation is huge. I do not want to air seal houses that don't have ventilation. How often do you guys want to breathe fresh air? All the time. Why would I put a lid on everything? So I've had people say, well, why don't you leave the house leaky? Well, I showed you the doctor's office. I want to control where the air comes in, but I'm not going to cut off your air. Unfortunately, the code, this is where ASHRAE and the code disagree. Code says cut off the air. ASHRAE says, whoa, let them breathe. Okay, we have to be responsible to do both. That's the issue. So dehumidification, I may need it. Combustion appliance zones, makeup air, understanding all of this. Rule number 1 never changes. We don't seal without mechanical ventilation. I do this, not the opposite. So that being said, I want my thing to advance. I think we just locked it up. There we go. This is the ASHRAE table. Hopefully you guys have seen it. If not, I love this table. The main reason is this shows me if I can keep the relative humidity. Humans function best between 40 and 60 relative humidity. Bacteria, viruses, fungus, mites, respiratory infections, all of these struggle in that range. It's funny, the things that want to kill us love when they love an environment that's not between 40 and 60, and we thrive in an environment between 40 and 60. This is what I want to create. So Dr. Joe says you can't build to ASHRAE 62.2 in the 2015 code. It's not possible. That's where we're getting this. When we look at this and number of bedrooms and all that air we got to give people, we need to look at this. How many of you guys see fans installed this way? Why do electricians and HVAC guys not understand that the house, the side of the house is over there? They can turn it. What the heck? My gosh. And then, let me ask you this. So you guys come to my McDonald's, order that triple thick shake, because it's hot outside. How are you going to look at me when I give you a flex straw instead of a straight straw? Do you think you're getting any milkshake today? We got to think of it in simpler terms. So here's the thing. This builder grade, my wife says I'm a cheap blank, but anyway, this builder grade fan was designed in a shop that was not air sealed, and it was tested with straight pipe. And they said, we made a fan that did 50 CFM. Here you go, buy it. So when I put the lid on the house, I take it down to 3 air changes, because that's what the code tells me, not ASHRAE, and I tighten this whole place up, and then I decide to throw a flexi straw on it. How well does it work? This is why you can smell your partner the next day. No, I'm kidding. It is why, literally, we are not taking moisture out of houses anymore. They may go in and turn the fan on, but it doesn't work. It's not getting the moisture out. So we have to look at, even when we make a 90, we don't want to make a 90. Sweeping or straight. Those are okay, but you have to look at this. When you look at this, you take off 15 feet for every elbow. Well, here's the chart of how these things work. So if I've got a 3-inch duct, I can put 5 of smooth wall duct on a 50. That's it. If I'm going to go to flex duct, I've got to go 4 inches, and here's a 50 on flex. I can go 114 feet with smooth wall duct. That's the difference. That's literally how much it takes out of that. And that's without tightening the house. That's just the chart. So you look at this guy isn't even turning it on. So what's the difference? Well, I will never foam a house myself. I'm not telling you guys what to do. We're on building science. Remember, this is not code. But I do not, as a foamer and as a builder, I no longer allow this to be your switch for my bath fan. I only allow this. You can turn it on when you go poopy, but you can't turn it off when it's too wet. It's a humidistat. Even Home Depot sells them. Just like that's where that one's from. You'll find every picture I rob off of Google. I plagiarize everything. Send me photos. Anyway, the issue is I won't let them be in control of the moisture. I don't want it left in the room, so I automatically throw in a humidistat. That's just my rule. But HVAC sizing, for those of you that have never been an HVAC contractor, this is probably my favorite argument. To understand how a mechanical system works is one of the best things you can know as a homeowner, because then you're going to pay attention to your system instead of your temperature. There are two loads in a house, the latent load, which is the water, and the sensible load, which is how I feel. The way the system works is I'm going to take a gas and I'm going to press that gas back into a liquid. That takes a lot of pressure. It takes a lot of energy to do that. That's done at a compressor. Then I'm going to take that oil all the way up to a condensing unit, condensing coil, up in the attic. And I'm going to let it turn back into a gas, and it's going to rob all the heat out of that thing. That takes about 4 minutes. If I super insulate a house, now let's say I set a glass of ice water on the table in this room. Does it immediately have water on it, on the outside of it? No, it takes a while for that water to come out of the air and attach to it. Probably 8 minutes. If my system, because I've super insulated this house, turns off in 4 minutes, I have removed 0 moisture from the house. So when I have a system that turns on and runs 10 minutes, I've removed 0 moisture from the house. We have to start properly sizing mechanical systems. Most spray foam houses need to be about 1,000 square feet per ton. That's why Aspen did what they did. We've gone 1,200 square feet per ton, never had problems. We have problems below 800. So be very aware of the way the system works. If the system is not running long enough to remove moisture, we got a problem. And I don't like, and I'm not in the business of selling mechanical, obviously, with this statement, but I don't like 21, 22 SEER units. The reason why is what I've done now is I've taken a system that worked beautifully. I took a real hybrid system, and then I'm going to shut off the coil and let the air keep going by. That gives me my additional SEER. What am I doing?
Dragging moisture off the ball.
Exactly. I'm taking the last of the moisture on the coil and putting it back into the house. It's not what I want to do. My problem is no longer cooling. The way that we're building, my problem is no longer the energy. It's what I've created. Exactly. Moisture in the home. So I was talking to a builder on the break, and they're having wood floors separate. They're having things fall apart because it's dry right now. Well, it's dry in the winter. But the solution was put in a humidifier. I will tell you, when you look at that ASHRAE chart, we don't really want to give homeowners humidifiers. That building, once we put people in it, selfishly they're going to want to shower and poop and eat, and they're going to make lots of water once we put them in there. So I would probably look at going to a humidifier for construction, maybe a plug-in one, if that's, if you're having problems with the wood floor. But I would not leave a homeowner a humidifier. I would let somebody install that afterwards, and it's not on my liability. So just covering that real quick. But certainly manual J's, rem rates, and I'm glad you said, I think it was you, Chuck, that said everybody's doing manual J, correct? Okay, so on manual J, we need to cover one thing. There's what I would call I'll use the word good, don't take that wrong. But there's a good manual J and a lazy manual J. And you'll understand what I mean by that. If I put in, I told you my house had, I had 20 air changes on my house. Well, I've also got homes that are at 0.6. They're called passive house. So between 0.6 and 20, there's at least 21 numbers. Would you agree? A lazy manual J, there's 5 numbers that I have to put into that system to get a legitimate manual J on a lot of different programs. I can put in 1 is tight, 2 is medium tight, 3 is medium, not so tight, and loose. I got 5. That manual J is nowhere near as accurate as if I truly put in all of the factors, including my actual air changes. So again, to me, if you're not testing, you're guessing. And if you can't measure it, I don't believe it. So, but we can talk about manual J's, right soft, rem rate and all that. But ductwork exposed to attic temperatures, 0 to 170 degrees, usually they're R4 to R8, just like you guys said. You nailed it. So we look at this, mechanical and conditioned space, definitely it's going to decrease your loads. I know that says decrease sensible and latent. Yeah, maybe, maybe not. Just because I've moved it into conditioned space doesn't mean I've lowered the moisture. But, heat and gain and loss across the ductwork certainly changes. You get no duct leakage to the envelope, and lower air infiltration should mean less moisture. That depends on where we're at in the country. I can't really make a blanket statement with that, but ductwork insulation is not required when it's in conditioned space. So, and it may increase the HVAC lifespan, but I've got to properly size. No longer do we use rules of thumb, ever. So, going, well, my grandfather said 500 square feet per ton, my dad did 500 square feet per ton, I'm doing, no, we can't. We have to right size or dehumidify, talked about that. A 5-ton air conditioning unit will remove 50 gallons of water a day. That's pretty incredible. Now that's when it's really rocking. That's it full on. The best dehumidifier in the industry does about 25 gallons a day. So half as much. I can't get there through dehumidification. I have to right size. Just because somebody built it wrong, I really don't want to let that go, because I can't make up with a dehumidifier all the time. I will tell you in some areas, Houston, Corpus Christi, Florida, we can't get by without dehumidifiers because there's too many days when we super insulate that the whole system never turns on. If you guys understand phase change materials, that's where we really get to the kick butt insulations. Because think of it like this, water boils at 212. Can you boil water hotter than 212? Not without a pressure cooker. What if I had a chemical that boiled at 80 degrees? Could you get it hotter than 80 degrees? Nope. And it freezes below 70. It's called a phase change material. What we've done now, and I'm not telling you guys to require this, you can't do this, this would raise the cost of building incredibly. It's $2 a square foot. But when you look at this, we've done them in U-Haul in Arizona, right above the drop ceiling tile. It's a phase change material. What it is a pillow, 1/4 inch thick, and it's a gel. This gel boils at 80 degrees, it freezes at 68, so at night the gel freezes. So they walk in the morning, it's 68. It's 68 all the way till about 1 o'clock when it's finally boiled all the way through, and then it's 80 and the mechanical system's running. It's incredible. So now the mechanical system never has to address anything higher than 80 degrees. We've got one of those as a house at 8,000 square feet in Colorado. The mechanical system hasn't turned on in 2 years. So when I say when we super insulate, we super insulate. So we have to do dehumidification in that case. We got to get rid of the water somehow. So anyway, talked about Richmond Middle School. I do not like water heaters in foamed attics. I don't like it. I don't like it. This is not water that's up in this open cell foam. That's acid. That's why the top of it's rotting out. But anyway, so rem rate modeling software. Then we can talk about, STC and NRC, the sound transmission, noise reduction. I love this for NRC. Just take on the bottom, if you've got a 2-story home, take on the bottom and just use sill sealer on the bottom of every joist and separate that sheetrock. You're not going to gain as much as when you use the clips and suspend it, but you're going to gain a lot. So it's just a freebie. But anyway, there is so much more to this. I wanted to cover a few things. Wind-driven rain obviously can enter through an attic. Gas embers can. This is also why California has gone to closed attics. They want them anywhere you're near urban wildlife or urban wildfire, because the grass is actually what catches most of the attics on fire, not the trees. It's that little ash that they've seen it in video clips where it looks like a blow dryer forcing little bitty sparks in until the place catches. But, other topics, I want to cover nominal versus full fill. All of spray foam generally uses what's known as nominal fill. Well, nominal, there's actually a filling requirement. There's only 5 sides required when you fill a cavity. That dead air space with spray foam actually counts. You can get half an inch to 1 inch, actually counts as R5. It's hilarious. I don't know that I agree with it. I call it voodoo science, but from an engineering standpoint, it's legit. It does not have to touch all 6 sides. There was a rule as to why insulation had to touch 6 sides, and that was that craft face is dangerously flammable. And they do not want a gap where that is. It is extremely flammable. Anyway, back to nominal. Nominal does not mean, when I say nominal, being a variance of less than 3/4 of an inch, a nominal 3.5 inches does not mean I'm going down to 2.75. It means 3.25 to 4. Well, they're going to shave it off. So nominal does not mean this guy can automatically just start poking holes at 3/4 of an inch away from the surface and tell you that's nominal, it's full. No, you want to make sure that it's at least up there, but it's designed so that we don't throw a bunch of stuff away. Now, vapor barriers, open cell foam, and roof decks. I know you're a 4. Open cell on a roof deck, on a really cold year, you're going to have vapor head for the sheathing. Here it's going to dry out. Zone 5, you're really supposed to coat it with a vapor barrier primer. Or use closed cell. One of the two. So just be aware of that. You don't have to coat it with a vapor barrier primer, but if it's my house, I'd do it on mine. It's not code, but it's just open cell foam's got open cells. So zones 5 and higher, you do have to coat it. Dew points, I showed you the chart in the SPFA. Exposure during construction. I told you we spray the outside of a lot of buildings. Closed cell foam can be left exposed in the sun. It will cause chalking. But 6 months to a year is not even a problem. It'll, now if you're going to put a coating on it, they probably are going to have to take a curry comb to it. If it's been exposed for 6 months, there's definitely going to be chalking and you'll have adhesion problems. FEMA, I talked about the 72 hours on flood. Job site ventilation and reoccupancy. It's 24 hours. Trades can come in 12, but all of the manufacturers have a 24-hour reoccupancy after we spray foam. So that's pretty straight up. Open combustion and makeup air, we talked about that. I just wanted to make sure I went through those. So let's see, time-wise, hey, 11:59. Totally, well, you had a question, I blew you off earlier. I am so sorry. Yes, let's do lunch.
Yeah, let's do that. Come back, everybody, we've got barbecues here. We're going to start the line right here. Come out the other side and drinks over here on this side. Just everybody be polite, go through once, make sure everybody gets food. And
What?
then come back through if you want to stay.
Load your plate.